So now that you've downloaded the Food for Rhino plugin and the Flounder plugin, I'm going to start with the Wallmaker example. So the quick example of the Wallmaker plugin is that it takes lines and turns them into walls. We're using basically just basic extrusion to do so. But the point of this Wallmaker plugin, or Wallmaker tool, is to explore and to explain the basic structure of what a tool is or how a tool is constituted. So the first thing I'm going to do is I'm going to draw a series of lines. I'm going to do this step by step to kind of show you how the tool is slowly built up. And I'm going to grab a geometry component, and I'll right click on it, set multiple geometries. So now in this I have two geometry objects inside of here, and I'm going to use the extrude component in the Z vector to extrude these lines. You can see they're extruded but only by a tiny bit, so I'm going to use a slider. You can type in slider, or I can also do a shorthand where I just type a number in and it gives me a slider kind of automatically. So I'm going to use a slider to adjust the height of these walls. And then the last thing is I'm going to use the preview object, and I'm going to plug that into the preview component. I'm going to use the swatch component to control the color of these walls. Let's make it a kind of a cyan or a bluish color for the time being. So now I have essentially this thing that just takes lines and extrudes them. But one of the things about tools is that tools become kind of augmentations of prosthetic processes, not just because they can do new things, but because they can do new things faster. So, you know, I can add a new line and right click on it and set multiple geometries, or I can use this thing called the geometry pipeline. The geometry pipeline is in the parameter kind of menu and here. And one thing to consider as a side note is that if you don't see a lot of objects or components in this menu, you have to go up to View and turn on Obscure Components. So in this pipeline will take any geometry that's on a certain layer that has a certain name and with a certain type and plug it into the geometry object. So in this case I'm going to rename this layer wall lines, and then I'm going to ask geometry pipeline to grab the layer wall lines. I'll right click and say okay, grab curves, and if I do that and plug this into geometry, you can see that the geometry pipeline object itself is getting these three curves. And now instead of adding new geometry and having to right click on this component to set the geometry, etc., I can just create new lines on this layer and it automatically grabs it and creates, extrudes, and does the entire process. Deleting objects is pretty easy too. So you can see that this process all of a sudden becomes very quick. There's a quote by Linus Torvalds, the creator of Linux, who says that innovation happens not when new technologies are enabled, but when existing technologies become faster. So in this case, you know, extrusion is nothing new, obviously, but the speed of it itself starts to augment your process. The fact that you don't have to go in and right-click and delete, that you can just kind of make new lines itself, could start to augment your process. The other thing I'm going to do is I'm going to take this slider, which is actually the height of the wall, so I'll call it wall height. And I'm going to right click on it and click on Publish to Remote Control Panel. What that does is it adds it to a remote control panel that was recently added in Grasshopper about half a year ago. In order to enable that, go to View, and if you click on Remote Control Panel, this window should kind of float around. This window is actually part of Grasshopper, but also kind of fits perfectly within the Rhino interface. So if you drag and click here, you'll see that it kind of snaps into the existing menu. Whoops. You can kind of rearrange things around, change the size. And so you can see that the slider has turned into a separate kind of control panel user interface element over here instead of in Grasshopper. You can do the same thing with swatches. So that if you right click on the swatch, or if you double click on a swatch, you can change the color. And this is essentially just exposing whatever UI tools in Grasshopper and showing them in Rhino. The advantage of this is that when you close Rhino, when you close Grasshopper, you can have all these tools on your right-hand side as if it were a separate interface, where in reality you're controlling Grasshopper. So that's pretty fun. And maybe one thing I can do is to minimize these two other windows and start to set up a view that's more perspectival. I'll use dolly zoom to kind of increase my focal length so it looks more like a perspective. And I'm going to turn on the camera. I'll either click on show or type S. And so in plan view you can see where this perspective's camera is and which way it's looking. So I can delete all these lines. I could start to say design and plan. So let's say I'm creating a parallel hallway that looks like this, and maybe there's another series of hallways that are relatively parallel, and maybe there's like a room that comes out. And you can see that designing and plan has repercussions in perspective, so there's kind of this immediate kind of process in which I design and plan, I see it in perspective. Great. So I'm going to go back into Grasshopper and do a kind of very simple data analysis. What I'm going to do is I'm going to get the area of the walls. And if I use the area component, I'll double click, type area, and plug this into here. And I'm going to open a panel. Here, the shorthand for panel is a quotation mark, so if I do that and I plug that into the panel component, I can see here all the area values I'm getting. These are square feet in this case. I think my units are incredibly huge, so these are like incredibly huge walls. I'm actually going to go and Rhino scale everything down just for the purpose of this exercise. I'm going to change the slider so that our walls are only about 11 feet tall instead of 100 feet tall. And when I do that, it looks like my square footage has become a little bit more reasonable. And so what I want to do is I want to take these walls and kind of color code them based on which walls or which segment of walls is big or small in relation to each other. In this case I have a series of B-reps, but you can notice that they are actually a series of wall panels that at some point sometimes are connected or sometimes are just one long surface. So this is a poly surface and this is a normal surface. So what I'm going to do is I'm going to deconstruct the B-rep or explode it to its constituent parts. I'll get the faces. So now I'm getting 7 faces. And I'm going to plug that into area, so now I get 7 different areas, which is great. I'm going to plug this geometry into the preview, so I'm just displaying 7 different chunks instead of 5 chunks, or 5 surfaces. It's 7 surfaces instead of 5 poly surfaces. Now, if you see these dotted lines, if you know a little bit about Grasshopper, you'll know that that means that they're part of trees. And trees are a very kind of powerful and relatively complicated subject in Grasshopper. It's essentially the way that all data is structured. I won't go into trees in this tutorial because I have another tutorial that deals specifically with trees and what they are and how to use them. But I'll do this one gesture, which is to say right-click on the F and say flatten, which makes all that structure, it throws it away and just gives you like a very clean or very unstructured list of data. And that's because all I want is a list of surfaces and a list of areas. Later we can go into detail about how to deal with trees and what kind of things you can do with them. Don't worry if you're confused by trees at first, because trees, if you master trees, you can master Grasshopper, and so there's a little bit of kind of conceptual understanding that has to happen. Again, watch the other trees tutorial for a better kind of in-depth understanding of what trees are. So I'm going to get the area, and I'm going to do this thing where I create colors. Now I'm going to use this color component called color RGB, where essentially you give it a series of floating point values, 0, decimal numbers. So a value from 0 to 1 goes into each red, green, and blue value, and if the red value is 1, then there's lots of red, so 1, 1, 1 equals white. If red is 0, blue is 0, and green is 1, then the color is green, etc. So I can use this to actually color code the walls. If I plug this in directly to the preview, you can see that I can start to control the color of the walls over on the left in the Rhino window. One other thing I'm going to do right now is there are all these points that are kind of distracting me, so I'm going to grab everything but the preview element and middle click on it and click on disable preview. That just means that whatever this is, it won't show up as geometry in the Rhino window. This is sometimes helpful because if you have a lot of stuff going on, it may display in Rhino, it may be confusing. So now that I have this, I'm going to, what I need to do is I need to turn these area values into floating point values between 0 and 1. So I'm going to use a component called remap numbers. What it does, it converts values, very different kinds of values, and you give it a source domain. So you say if you have a bunch of numbers between 0 and 1,000, it maps those numbers to 0 and 100. So I'm going to use the bounds component, which if you give it a bunch of numbers, it will give you the outer bounds. So all these numbers are between 66 point something and 1213 point something. So that's our source domain. The values themselves go into V. And T is the target domain, so we say, okay, yes, by default it's from 0 to 1, and we want to map all these values which have the source domain to that target domain. So if you see what comes out of R, the remapped number, you can see that, yes, the values have been remapped to a range between 0 to 1. And since the floating point RGB takes these values, I can kind of plug the 0 to 1 value into one of these, some of these numbers. And so as a result, we also get a series of 7 colors that scale from that scale accordingly as different colors. So this is going from white to blue. And so here it looks like what's going on is that the shorter walls are the bluest and the larger walls are the whitest. Let's say that that makes sense for us. For some reason, it costs more money to paint smaller walls, or maybe you don't want any smaller walls in your building. That's fine. So if that were the case, you know, whatever walls I draw will be color coded based on their length. So you notice that long walls are white. A long wall with a little short wall attached to it, that short piece will be blue. A medium-sized wall that zigzags and gets smaller, you know, may appear to be more of a gradient. So right now, all of a sudden, I've created some sort of data attached to data representation attached to the tool that is also telling me what I'm doing right or what I'm doing wrong. If we're going to turn the camera off really quickly. If my goal was to create a space with as many large walls as possible, you can see how I would start to kind of want to delete the blue walls because I wanted only large, long expanses of walls, perhaps. Choices like these that are about choices in terms of this kind of data analysis and then how you represent it eventually end up affecting how the user uses the tool. Now the last thing we can do is we can do something like get the total square footage and maybe give it back to the user as some sort of number. So if I have all these area values, I can add them together. I'll use mass addition. It gets a bunch of numbers, just adds them together. And I can say, okay, well this is total square footage. I can right click on it, and click on publish remote panel, and it'll come out here as a number. I can click on this edit panel button and I can add a label which I can drag up and down, and I can right click on it and say I can I can right click on it and call it total square footage. And so this user interface too I can rearrange and add labels for. So if I increase the wall height, the square footage goes up. You know, I can move it around. I can add new walls, and you know, I can view it in perspective while I'm designing it in plan, We can increase the wall, make the wall taller, delete everything, start from scratch. This is kind of the basis of how we're creating tools. And if you try this out, you'll find that it's kind of interesting to play around with just creating different lines and seeing how they manifest. And again, the core kind of computational dynamic here is nothing. It's essentially just an extrusion operation. But what's being created is a little different, or feels different than just extrusion. Perhaps it's a tool that lets you make walls that pushes you towards making as large walls as possible. Or maybe it's the other way around, where if you change the color to actually be more reddish, then it makes and then you invert the scale so that instead of going from 0 to 1, you go from 1 to 0. You might say that you want a building with as many small walls as possible. So I'm going to say use construct domain. I'm going to add a slider that goes from 1 to 0 instead of 0 to 1. So now the longer the wall, the redder it is, and so it's in your interest to delete the long walls as possible and make everything be about a series of short walls perhaps. So maybe if you're designing a maze, this is exactly the kind of tool you want to use, because you're worried about long stretches, and so you want your walls to be all as narrow and windy as possible. This is the kind of coloring kind of process you would use. The last thing I'm going to talk about here, which makes more sense in the next tutorial, the spider sack tutorial as I call it, is the syncing cameras. Now when you installed or downloaded the plugin, there are these 3 different operations. The first one, you give it a viewport name and a Boolean toggle, and it gives you all the information about the camera. The second one, if you give it location and target and lens, it changes the location of the camera. The third one actually syncs 2 viewports together. So what I'm going to do is I'm going to create 2 viewports that are synced, and show you how to display different information on each viewport. So I'm going to go and set view and go to name views. And on the right, I'm going to call this viewport, design viewport. On the left, I'll change this to a perspectival view, and I'll call this model viewport. Now you've noticed that I've spelled viewport wrong. I'll leave that because, as you can see later, I can use wildcards. Well, I might as well just change it now. Design viewport. Great. So here, if I use the panel component, I'll say model viewport. Make sure there's no spaces or returns. I'm going to type model viewport, and I'll plug it into the source viewport, and I'll say, well, design viewport is what I want what I want to be synced with the model viewport, and I'll get a Boolean toggle. Basically, it's a switch that's between yes or no. And I can say, if I set this to true, let's see. I see that I still have a typo here. We're going to go to set view, named views, and call this, invoke this here. Great. So now if I turn this off and turn this back on, you notice that these 2 views are synced. But that actually doesn't maintain itself. And the reason why that is because this component only triggers once when I turn this on. I want it to be continuously triggering. So I'm going to use the timer component, which is a mechanism that continually triggers a component, so it's like recalculating and resolving over and over again. I'm going to click on the red button, the red arrow, and if I do, you can see that this dotted line comes out. It's different from other lines in Grasshopper. I'm going to connect it to this component, and when it says 1 second, it means that it's going to refresh every second. You can see that it's already refreshed over here. If I right-click on it and set the interval to say 100 milliseconds, as I move this around, it's refreshing once every 10 seconds. And if I change this to 20 milliseconds, it's refreshing 50 times a second, so it's pretty smooth. So you can see that these two views are kind of seamlessly kind of synced together. You can actually do this with multiple viewports, but I won't do that right now. So the nice thing about this is that you get these two different viewports, and using the custom preview function, there's a viewport filter function. You can choose what to display in what viewport. So one thing that you may want to do is, for example, you could say, oh, this color coding aspect you only show in model viewport. And then in designer viewport you only see the lines. Or vice versa. Perhaps that's so you only see the lines in model viewport, yet you see the walls in design viewport. So that's one way in which you can kind of decide what kind of information to show and what not. This is the reason why this is valuable as a tool is because it lets you kind of separate out or create interfaces in one view and see what it looks like in another view, all within the Rhino window. This will make more sense in the SpiderStack tutorial, but I'm going to minimize Grasshopper and expand Rhino, and now we're at a point where it looks like we're just drawing lines. I'm changing the wall height. I'm playing around in Rhino. I can move it around. I can very clearly see what lines I've drawn. What we can also do is we can go in and edit the points and move the points around and see that change, then update, etc. So what we've done is a very kind of simple and small example of a tool. In terms of the process, thinking about the process, what we've done is we've created a way to grab geometry. We've then grabbed the geometry and extruded it, or done some geometric operations onto it. We've done some basic calculations, in this case getting the square footage of each individual panel, and then we represent it. We use, for here, we use color coding to color the panels or the walls based on their square footage, and then we represent it in two different viewports, and then we also set up a kind of a two viewport system in which we have this interface where we edit in one and kind of see results in the other. These are all small step-by-step technical changes that together may cohere into an interface. Oh, and of course we've also created this remote control panel where we can remotely affect the height of the walls and see kind of the total square footage of the walls change. So this is kind of the basic structure of a tool. And again, I need to reiterate that the mechanic of extrusion is actually really simple here. This could be anything. This could be lofting. This could be movement, etc., etc. So it's not the importance of this tool is not that extrusion is complicated and does that for you. It's that it makes certain things faster, or it's telling you certain things about its process while you're using it. If we're highlighting the small areas of these walls red, then perhaps the tool is communicating to us or to the user that those parts are bad or good, etc. If you want to go on to something a little bit more advanced, which I highly recommend, you should try out the SpiderStack tutorial, which incorporates the same kind of interface and introduces it a little bit again also, but in the service of creating a tool that's a little bit more like something you would not be able to do in in Rhino proper. But I think it's important to understand that the basic dynamics behind the tool are the same, or that the most important aspect of what the tool does is not necessarily in its technical complexity, but more about how it communicates information to the user. And as a designer of tools, I think our role, or your role, is to think about what it is the tool does, and then how does it share that information with the user, and thus how does it induce the user to create new possibilities or think about new possibilities. In this case, we've just used the extrusion dynamic, sure, but whether it's this coloring of red or whether it's the height of the automatic extrusion process, hopefully this tool is something that makes users create walls more often, or twisty walls more often, or narrow maze-like passageways more often. I think it would be a success of one kind of tool, if this tool ended up generating maze structures that were more like mazes as opposed to hallways. Because the tool and its visualization and the way it communicates to the user induces that kind of design desire in the person who's using it and treating it, and ultimately having it used like a part of their kind of body.